All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we're going to take a look at how to solve systems without drawing a graph. In prior lessons, we solved systems using graphing, where we actually graphed the equations of two lines and we saw where they crossed, but you can probably imagine situations where you wouldn't have a graph available. You would just have the equations and you would need to know where they cross or the solution to that system of equations. And that's what we're going to learn how to do in this video. We're going to start with an easy case. The two basic methods for solving systems of equations are called substitution and elimination. And first we're going to look at substitution, and we're going to look at a very easy case. So I promise we'll go into great detail for both methods, but first we're going to focus on substitution right here. Before we do that, we'll look at a warm-up here, and this is a geometry builder warm-up to remind you of your geometry skills. Let's take a look at what's going on here for number one. In number one, we're asked to find the area of a triangle. And this little symbol down here in the corner means that we have a right triangle. The base is 2x and the height is x. And the triangle area formula is base times height divided by 2. So we just need to multiply 2x times x divided by 2. Let's see what that looks like. So base times height divided by 2 will be 2x times x divided by 2. Now, 2x times x, that's a exponent rule that we know. It's called the product rule. Both of the x's have an exponent of 1, and when we multiply two variables where the bases are the same, we add the exponents, okay? So this is equal to 2, we didn't do anything with the 2 just yet, x to the 1 plus 1 power, all divided by 2. Now, two things can happen in the next step. First, we can add 1 plus 1 for that exponent. 1 plus 1 is 2, so the exponent of x will be 2. That'll be x squared. And the second part here is I can cancel the 2's. So this will reduce down or simplify down to x squared. And that is the area of the triangle. Okay, the area of the triangle is x squared. And we should write units squared. We don't know what the units are, but you know, they could be inches, meters, whatever, but area is units squared. Okay. Now on to number 2. Find the length of the hypotenuse. Here we're asked to recall that the Pythagorean theorem is a squared plus b squared equals c squared. So we can arbitrarily assign a and b to either the base or the height. It doesn't matter. But c is always the hypotenuse. So this is going to be c. And we can give this 1 a value of a, and 2, that will be b. So now I know a, b, and c. I just have to find c. So in my work, what I'll write is a squared plus b squared equals c squared. So I'll write 1 squared, okay, because a is 1, a squared, 1 squared, plus b squared, which is 2, 2 squared, 1 squared plus 2 squared equals c squared, because I don't know what c is, and that's what I want to find out. So I get c by itself by taking the square root of both sides. So I'll take the square root of c squared, and I'll take the square root of 1 squared plus 2 squared. When I do that, the squared term goes away. When I take the square root of a squared term, the square root goes away. So I have the square root of 1 squared plus 2 squared equals c. And now I just need to figure out what these are, okay? So 1 squared is 1. 1 times 1 is 1. 2 squared is 4. 2 times 2 is 4. So what I've got is I've got the square root of 1 plus 4. Because 1 squared is 1 plus 2 squared is 4. Okay? And that's equal to c. So we're going to finish this off by saying 1 plus 4 is 5. So c is the square root of 5. This is called a special right triangle because it has this relationship 1, 2, square root 5. This is one that you'll want to memorize. There's a few of these, 2 or 3 of them at least, and you'll want to memorize these special right triangles. So c is the square root of 5. If you wanted to evaluate the square root of 5 out to some decimal places, you could use a calculator to do it. Square root 5 is 2.236067977. So we're going to leave it as square root 5 because this is called an exact figure and this is called an approximate figure. And we want to use the exact figure because this is an infinitely non-repeating irrational number. And we want to make sure that for irrational numbers, we leave them in exact form. Okay, otherwise we're just approximating it out to some number of decimal places. Okay, so much for 1 and 2. Let's look at number 3. We're asked to find the area of a circle. And we're asked to recall that the circle area is pi times r squared. Here we're given the information that r is equal to 3x squared. I should probably write that down. R equals 3x squared. So what I need is to square r, okay? So down here I'll do this work. R squared is equal to 3x squared squared. Okay? When I have something squared raised to another power like this, 3x squared squared, I multiply this final exponent by every term inside the parentheses. By the exponent of every term inside the parentheses. So 3 has an exponent of 1. We need to know that because I'm now going to multiply the 2 times each exponent inside the parentheses. So here r squared equals 3 squared times x to the 2 times 2. And that means that is equal to 3 squared is 9. 3 times 3 is 9. So 9x, 2 times 2 is 4. So 9x to the 4th power. And that's r squared. Okay? So we now know what r squared is. And the area of the circle is pi r squared. So we can say that the area of this circle is equal to pi times 9x to the 4th units squared. Okay, because area is written in whatever units there are squared. And that's not very clean, so we're going to write that like this. 9x to the 4th power pi. We're not going to calculate pi because pi is irrational. It would just go on forever, 3.14159.265, etc., 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 forever and ever. We'd only ever have an approximation, so we leave it exact as that symbol pi. Units squared. Okay? And this is where geometry and algebra meet. All right? So, now we'll move on to the final problem. Find the volume of a cube. Okay, and we're given a bunch of information here. First, we're a cube. I said cube. Find the volume of a cone. And here we're given a bunch of information. We're given that the height of the cone is 3x, and the radius of the cone is x. It says here that the volume of a cone is 1/3 times pi times r squared times the height. So we just need to plug in the values that were given. Right? So if that's the volume of a cone, then our volume of our cone, okay, the volume of our cone is equal to 1/3 times pi. And now I need to do r squared. Well, r is x, so x squared times the height, okay, times 3x. Now I can simplify that. I can make that more compact because 3x has an x has an exponent of 1, and I'm multiplying x to the first times x to the second. So this will give me 1/3 times pi times x to the 2 plus 1. I'm adding those exponents times 3. Okay? What I'm going to do next is bring this 3 over here to hang out with the 1/3, and I'll have 3 over 3. 3 times 1/3 is 3 over 3. So we'll set this equal to 3 times 1/3 times pi times x cubed. Okay, well 3 times 1/3 is 3 over 3, and 3 over 3 cancels. Okay, I cancel those 3's and I just have 1, right? So we don't need to write the 1. We can just write x cubed times pi units cubed. Okay, this is the volume. We always write in cubic units, the volume of our cone. Okay, so we've solved all 4 problems. And now we move on to the lesson content. How to solve systems without a graph. So we don't have a graph. And I said we were going to use this first method called substitution. And I'm going to let you read. What is substitution? Okay, solve for one variable and use the solution to solve for another variable. Just reading that doesn't make much sense. Let's do an example. Imagine you're given a system with 2 equations. Remember, a system has to consist of at least 2 equations. And the first equation reads y equals 4x minus 8. The second equation reads y equals negative 4x plus 8. All right, so first of all, notice that the equations are both already solved for the variable y. That's why this is an easy example. We don't have to solve for anything. We've already got the variables isolated. We have the y variables isolated. So here's a bright idea. Drop the y's and set the rest of each equation equal to each other, and then solve for x. Then plug what x equals back into one of the equations and solve for y. Again, I've got this little kind of thinking emoji here saying, what does that look like, bro? Because just reading that, it doesn't make a lot of sense. Here's what it means. If y equals 4x minus 8 and y also equals negative 4x plus 8, then I'm going to drop these y's. Y is going to disappear. Now I have this part equal to this part. 4x minus 8 equals negative 4x plus 8. And what you see here is me solving for x. First, I add 8 to both sides. Then I have 4x equal to negative 4x plus 16. Okay, now to get the x's together, I add 4x to both sides to move x over to the left side of the equation. Then I divide both sides by 8 to get rid of the coefficient in front of the x variable. So the 8's cancel and x is equal to 2. Because 16 divided by 8 is 2. You know, here's the alarmed emoji. Now, why are we doing all of this? We did this in order to discover that x equals 2. And now we know x. We know what x is. This is very valuable to us because if we know one of the variables is 2, we can solve for the other variable by plugging 2 back into one of the equations. That is, in fact, what we're asked to do next. If x is 2, then we could plug it back into one of our equations everywhere we see an x, and then we could figure out what y is. So, if y equals 4x minus 8 and x equals 2, then plugging 2 in everywhere I see an x, and I only see an x right here, then y equals 4 times 2 minus 8. So I plug the 2 in where I saw an x. So if y equals 4 times 2x minus 8, or y equals 4 times 2 minus 8, okay, where x equals 2, y equals 4 times 2 minus 8, then y equals, 4 times 2 is 8, y equals 8 minus 8. So y equals 0. So now that we know x equals 2 and y equals 0, we know what the solution to the system is. The solution to the system is 2 comma 0, or x comma y, 2 comma 0. And here's proof. What I've done here is I've graphed both of the equations, and I say, see, the lines cross or intersect at 2 comma 0, right here. So this positive slope line is the equation of 4x minus 8, y equals 4x minus 8. This negative sloping line is the equation y equals 4x plus 8. And you see where they intersect on the x-axis at 2, so the y value is 0, so they intersect at 2 comma 0. So we have actually solved for the system of equations without a graph, but I proved it using a graph so you could see it. Okay, so that's kind of the lesson content right there. That's the example. And what we've acquired today is the ability to work with equations that are already solved for y. We know what to do with them now. We drop the y's and we set those equation parts after the y equal to each other, and we solve for x, and then we plug that x value back into one of the equations and solve for y. So let's move on to some practice problems. Okay, we're going to solve each system using substitution, and this is the easy case. So we're going to do the same thing we just did. In this first example, we're just going to drop these y's, right? We're going to set these equations equal to one another and solve for x. So negative 2x plus 2 equals negative 4x plus 8. And now we just need to solve for x, right? I'll solve for x on the right side so I don't end up with negatives, plus 2x on both sides. Negative 2x plus 2x is 0. 4x plus 2x, negative 4x plus 2x is negative 2x. Now I have 2 equals negative 2x plus 8. Okay, I'm trying to get x by itself. So I'll subtract 8 from both sides. Two minus 8 is negative 6. 8 minus 8 is 0. So now I have negative 6 equals negative 2x. Okay, to get x by itself, I'll divide both sides by negative 2. On the right side, the negative 2's cancel. And on the left side, negative 6 divided by negative 2 is 3. Therefore, and this is the symbol for therefore, those 3 dots mean therefore. Therefore, x equals 3. So now I know what x equals, and I can plug that back into one of my equations. So we'll plug it back into the first equation. Y equals, so I'll now solve for y, negative 2. Now x equals 3. So I'll put a 3 here where I would have put an x plus 2. Okay? So y equals negative 6. 2 times 3 is 6 plus 2. And negative 6 plus 2 is negative 4. So y equals negative 4. So I have x equals 3, y equals negative 4. So the solution is 3 comma negative 4. That would be letter A. Okay? So I've now solved for one of these, and you now have a few more practice problems to do. You can do it. Just follow this process and you can do it, I promise. This is also how you solve all the homework problems. So I hope this video was helpful. If it was, please give it a like. And if you have a question, leave it in the comments section. If you have not already, please subscribe to the channel and hit that notification bell so you're always alerted to new videos on this channel. Thank you.